we have some givens. We have C sub 1. The first capacitor has a capacitance of 3.70 microcoulombs, or we can say 3.7 times 10 to the negative 6 farads. Sorry, microfarads. My apologies. And this is when it's charged. And we have V equals 12 volts and C sub 2 equaling 5.0 microfarads, or we can say 5 times 10 to negative 6 farads. And again, this is uncharged. So part A is asking us for the stored energy before the two capacitors are connected. So this would simply be equal to PE equals 1/2 C sub 1 V squared. So this would equal 1/2 times 3.7 times 10 to the negative 6th, 12 squared. And we find that the stored energy before they're connected is going to be equal to 2.66 times 10 to the negative 4th joules. So this would be your answer for part A. This would be the stored energy before the two capacitors are connected. For part B, they're asking for the stored energy after two capacitors are connected. So at this point, we know that the total charge is going to be equal to the capacitance times the capacitance sub 1 times the voltage. Now, this is going to be equal to 3.7 times 10 to the negative 6 times V, so that would be simply 12. And this is equaling 4.44 times 10 to the negative 5th coulombs. Now at this point, we know that Q sub 1, the charge in the first capacitor, is equal to C sub 1 V. And then we know that the charge in the second capacitor is C sub 2 V. So we can say that the charge in the first divided by the charge in the second is going to be equal to the charge in the first divided by the capacitance in the first will equal the charge in the second divided by the capacitor in the second. And we know that this is going to be equal to Q total minus Q sub 1 divided by C sub 2. So we know that Q1 is going to be equal to the Q total times C sub 1 plus C sub 2, and as C sub 1 is the numerator. So this would be the formula for Q sub 1, and then we can actually solve and say that this is going to be 4.44 times 10 to the negative 5th, and then it'll be 3.7 times 10 to the negative 6th, and then here 8.7 times 10 to the negative 6th. And we find that this is going to be equal to 1.888 times 10 to the negative 5th coulombs. Now to solve for Q sub 2, this is going to be equal to the total minus Q sub 1. So this will be 4.44 minus 1.888 times 10 to the negative 5th. And this is going to equal 2.552 times 10 to the negative 5th coulombs. Now this is important to note, as well as this value is important. So at this point, we can find the potential energy total. So this will equal the potential energy from one plus the potential energy from the second. And we have Q sub 1 squared over 2C plus Q sub 2 squared over 2C. And we say that this is going to be equal, rather let's get a new line, so potential energy total is going to be equal to 1.888 times 10 to the negative fifth squared divided by 2 times the capacitance. This will be C1, this will be C2. So here it would be 3.7 times 10 to the negative sixth. And then it'll be plus 2.552 times 10 to the negative fifth squared divided by 2 times 5 times 10 to the negative sixth. And we find that the potential energy total after the two capacitors are connected is going to be equal to 1.13 times 10 to the negative fourth joules. So this would be our answer for part B, rather. Now for part C, they're asking us for the change in kinetic energy. So this would be simply P final minus P initial. This would be equal to 1.3, or rather 1.133 minus 2.664 times 10 to the negative fourth. And we find that delta PE, the change in kinetic and potential energy and stored energy, would be negative 1.53 times 10 to the negative fourth joules. So the system is losing energy in part C. That'll be your answer for part C. That is the end of the solution. Thank you for watching.